Hello students, in previous lecture we know two properties of Jacobians. Then in this lecture we are going to learn another property, that is, if u, v, w are function of three independent variables x, y, z are not independent. Here given that u, v, w are not independent. Then we prove del u, v, w with respect to del x, y, z equal to 0. Now we prove that theorem. Here given that del our UVW are not independent. That is, there exists a function f. Such that our f of UVW equal to 0. That is our equation 1. Then here we know that del f by del x equal to 0, del f by del y equal to 0, and del f by del z equal to 0. As we know that u, v, w are not independent, but our x, y, z are independent variable. So del f by del x equal to 0, del f by del y equal to 0, and del f by del z equal to 0. Here in del f by del x equal to 0, we apply chain rule. That is, del f by del u into del u by del x plus del f by del v into del v by del x plus del f by del w into del w by del x equal to 0. As here given, it is the function of three variables. So in second, we apply chain rule. In here, del f by del y equal to 0. Here we get del f by del u into del u by del y plus del f by del v into del v by del y plus del f by del w into del w by del y, that is equal to 0. Then again lastly we apply the chain rule in here, that is del f by del u into del u by del z plus del f by del v into del v by del z plus del f by del w into del w by del z, that is equal to 0. This is our equation 2. Then by eliminating del f by del u, del f by del v and del f by del w, we write it is in determinant form. So we get del u by del x, del v by del x, del w by del x. In next equation, del u by del y, del u by del y, del v by del y, del w by del y. Then in last equation, del u by del z, del v by del z, del w by del z. Its determinant is equal to 0. In equation 2, we form a determinant that is equal to 0. Here we can interchange columns. We can interchanging the rows into columns. That is del u by del x, del v by del x, del w by del x. Here del u by del y, del v by del y, and del w by del y. Then here del u by del z, del v by del z, and del w by del z. Its determinant equal to 0. Here by interchanging the rows into columns. By interchanging rows into columns, we get this determinant. So it is the Jacobian of del UVW with respect to del XYZ. that is equal to 0. Here we have del UVW by del XYZ equal to 0, and see the theorems. That much we can prove. So then see one example, that is, if x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta, then prove that del xyz with respect to del r theta phi equal to r square sin theta, and del r theta phi by del xyz equal to cosec theta upon r square. Then first of all we find del x by del r. Del x by del r. Our del x by del r is sin theta into cos phi. Then next del x by del theta. That is, our del x by del theta is r cos theta cos phi. Then we can find del x by del phi is our minus r sin theta into sin phi. Next we can del y by del r. We can find del y by del r. It is our sin theta into sin phi. Del y by del theta. Del y by del theta is our minus, that is, r cos theta into sin phi. Lastly del y by del phi. That is, del y by del phi is our r sin theta into cos phi. Lastly del z by del r is our cos theta. Del z by del theta is our minus r sin theta, and del z by del phi is our 0. Then next we find del xyz with respect to del r theta phi. Now our del xyz with respect to del r theta phi, that is equal to del x by del r, del x by del r, then del x by del theta, del x by del phi. Next del y by del r, del y by del theta, del y by del phi, del z by del r, del z by del theta, del z by del phi. Its determinant. In previously we find the value of this del x by del r, del x by del theta, del x by del phi. Put it in this determinant. Put in this determinant, we get del x by del r is our sin theta into cos phi, and del x by del theta is our r cos theta into cos phi, and del x by del phi is our minus r sin theta into sin phi, and del y by del r is our sin theta sin phi, and del y by del theta is our r cos theta sin phi, and del y by del phi is r sin theta cos phi. Then del z by del r. Del z by del r is our cos theta, del z by del theta is our minus r sin theta, and del z by del phi is our 0. Then solving this determinant, that is, in this way we can solve. We solve this determinant in this row. Here first starting with cos theta. Cos theta, that is determinant of r cos theta into cos phi minus r sin theta into sin phi, r cos theta into sin phi, r sin theta into cos phi. Then next minus r sin theta, that is plus r sin theta. Determinant, in we can eliminate this column and this row. Then here we go, that is sin theta into cos phi, sin theta into sin phi, and here minus r sin theta into sin phi and r sin theta into cos phi, and if we multiply 0 then it last determinant term is 0. So we solve this determinant, that is cos theta into r square sin theta into cos phi and cos theta into cos phi, minus minus plus r square sin theta into sin phi and cos theta into sin phi. Then next plus r sin theta into sin theta r into sin square theta into cos square phi, minus minus plus r into sin square theta into sin square phi. In first term we get common that r square sin theta into cos theta, that is r square sin theta into here cos theta, that is cos square theta, that is cos square phi plus r square sin theta cos theta, then that is sin square phi. In next term we get common, that is r sin square theta into r sin square theta into r sin square theta, that is cos square phi plus sin square phi, cos square phi plus sin square phi. It is our 1 and it is also 1. So we can get r square sin theta into cos square theta plus r square sin cube theta, that is get common r square sin theta, then here cos square theta plus sin square theta, that is our 1. So we get r square sin theta. So our question to show that del xyz with respect to del r theta phi is our r square sin theta, and we get that del xyz with respect to del r theta phi is our r square sin theta. So one proof is there. Then another is del r theta phi with respect to del xyz. Here in this Jacobians now we find del r theta phi with respect to del xyz, that is del r theta phi with respect to del xyz, that is equal to 1 by del xyz with respect to del r theta phi. We can written it as 1 by del xyz with respect to del r theta phi, and it is our r square sin theta. Del xyz with respect to del r theta phi, del xyz with respect to del r theta phi is our r square sin theta, that is 1 by r square sin theta. This 1 by sin theta is our cosec theta by r square. So in next we can show that we have to show that del r theta phi by del xyz is our cosec theta by r square, and here we show that del r theta phi with respect to del xyz equal to cosec theta by r square. Thank you students.